All right, here is another example. Researchers are studying the vitamin C content that can be destroyed as a result of storage and shipment of the commodity to its final destination. Researchers specially marked a collection of bags at the factory and took a sample of each of these to determine the vitamin C content. 5 months later in Haiti, they found especially marked bags and took the samples. The data consists of 2 vitamin C measures for each bag, one at the time of production at the factory and 5 months later in Haiti. Here are the data. Now, if you look at this, each row, these two correspond to the same thing, or same sample. So we call these dependent on each other. So when they're dependent, what we want to do is find the difference of those and run a t-test on the differences. So here it says, is there enough evidence to support that the vitamin C is destroyed as a result of storage and shipment? So if the vitamin C is destroyed, we'd expect this number to go down from this number. So what we'll do is we'll put all of these factories in L1, and we take L1 minus L2 to get all of our differences. And we do those for each single value. But if you do it in your calculator, it's nice, quick, and easy. All right. Now, I'd advise you to do this problem, do the best you can, and check the answers. All right. Hopefully you're done, because I'm going to go through the answers. The first thing we want to do is look at the null hypothesis and alternative hypothesis. The null is that there's no difference between the factory and Haiti, and our alternative is that the mean is greater than 0, because if I subtract these two, if Haiti decreases, that means that this would be a positive number. We'd have to clearly define that mu is the mean difference of vitamin C from the factory to Haiti, and then make sure it's clear that you're taking factory minus Haiti. If you did Haiti minus factory, then you just want your mean to be less than 0. Now we have to check our conditions. First, the data do not come from a random sample. We have to assume that each difference is independent. For normality, we would have to graph it. Since we don't quite have 30, we graph the distribution. It looks fairly symmetric, so we can assume that the distribution is approximately normal because the sampling distribution is symmetric. Or I should say the sample is symmetric. We don't need distribution there. The sample is symmetric. All right, from there, what we do is we do the calculations. Our sample mean was 5.3, so we want to find the probability that we get a mean that's further away than 5.3. So we would take we don't know the population standard deviation, so it's a t distribution, where we take 5.3 minus our mean is 0 over our standard deviation, that was our s of x, over the square root of 27. Now, if I do the math here, I get 5.3, which is surprising that those are the same. That's just coincidence. And then the p-value is quite low, almost 0. So since the p-value is low, we reject the null hypothesis, and we have evidence that because the p-value is below alpha, we have evidence that the vitamin C is destroyed between the factory to Haiti. That is our other example. Hopefully that helps. Do some on your own.